Hello, my name is David Ferez, and today I will go over what is pH and a buffer solution. Well, I'm just going to talk about it real quick. I will then go over how to calculate the pH in a buffer solution. So pH is a measure of the acidity or basicity of a solution, and a buffer solution is a solution that resists change to pH. And so now we're going to calculate it since we went a little bit over what they were. And here we're given a buffer solution that contains an acid and a conjugate base. So when this dissolves after being put together, it would produce F- ions, which are conjugate base of the hydrochloric acid. So the way we figure this out is by figuring out the relevant equilibrium here, which is hydrochloric acid reacting with water to make H3O plus and F-. And so hydrochloric acid is aqueous, and all of them are aqueous except for water because it's a liquid. And so that means that the equilibrium expression for Ka is the concentration of H3O, which I have here, plus, and then multiplied by F- divided by hydrochloric acid. And the only reason why we didn't use sorry about that. The only reason why we didn't use water. And the only reason why we didn't write H2O is because H2O is a liquid. So we're going to use the ice chart to solve this expression. We start with the HF down here, which is 0.2 that we were given up top. And F-, which we were also given up top. We weren't given an H3O, so it would be 0. And that would be our initials, so the ones we started with. And for C, and the only reason why we have 0, we don't have a 0 here because, we start with the reactant and we end with usually no product. But since, here we start with 0.1, so we have to plug it in. And for the change, let's just assume it goes right for the reactants. So it'd be a -X for the reactants, and for the products, which are these two, would be plus X's. And so we put these two together, and that equals our equilibrium. And that's what we got. So we're gonna use this and we're gonna plug it into Ka. And also on this side of Ka, of the Ka expression that we're given. And this K, we were given the value of Ka. So we're gonna plug this on this side to figure out our pH. And so when we plug in the numbers, we're given this. And so this is a relatively small number. So what we're gonna do, we're gonna get rid of these X's and, assume that they were small numbers too. And so we're just gonna get rid of them. And we'll see if this assumption holds up later, if I'm correct. If they really are small numbers. And so what I did here was that we wanna solve for X, right? So what we do is, how do we bring this to this side? What's the opposite of division, which is multiplication? So on this side, we brought it here and then we multiply it to 6.3 to the 10th -4 power, right? And so the way we have a 0.1, and how do we get, what's the opposite of multiplication, which is division? So here we're dividing it. And so we plug this into the calculator and what we get is this. And that written out fully is X equals 0.00126. And compared to 0.1, that's relatively small. So I guess my assumptions were right. And so X, we were looking for X, which X, the only one that was X here is H3O plus. So that H3O plus is equal to, our H3O plus is equal to 0.00126. And so now if we want to, we can find the pH by taking the negative log of that number, which I have here, and that gives us 2.9, so that means the pH of it is 2.9. So the pH of this buffer solution is 2.9.